Hello, I am Rishikesh Devarmani. This is a short tutorial video on I2C protocol. Let's have first of all an overview of the presentation. First of all, we will see the introduction of I2C protocol, then the design, then the working of I2C, its advantage, disadvantage, and finally we will go through the applications. Introduction. I2C stands for Inter-Integrated Circuit. It is a well-known bus invented by Philips Semiconductor in 1982. It is a synchronous multi-master, multi-slave packet switched single-ended 2-wire bus having data rate of about 100 kbps, 400 to 450 kbps and 3.4 mbps. It combines the best features of SPI and UARTs. With I2C, we can connect multiple slaves to a single master and can have multi-masters controlling single or multiple slaves. This is really useful when you want to have more than one microcontroller logging data to a single memory card or displaying text to a single LCD. This is the design of I2C. I2C uses two bidirectional open drain lines, namely serial data line SDA and serial clock line SCL pulled up resistors. Typical voltage used are plus 5 volt or plus 3.3 volt, although systems with other voltage are permitted. Now let's see how I2C works. With I2C, data is transferred in messages. Messages are broken up into frames of data. Each message has an address frame that contains the binary address of the slave and one or more data frames that contain the data being transmitted. The message also contains the start and stop conditions, read or write bits, and ACK or NACK bits, that is acknowledgement and non-acknowledgement bits between each data frame. Start condition. The SDA line switches from high voltage level to low voltage level before the SCL switches from high to low. Stop condition. The SDA line switches from low voltage level to high voltage level after the SCL line switches from low to high. Let's see the address frame. A7 or 10 bit sequence unique to each slave that identifies the slave when the master wants to talk to it. Read or write bit. A single bit specifying whether the master is sending data to slave or requesting data from slave. ACK or NACK bit. Each frame in a message is followed by an acknowledged or non-acknowledged bit. Now let's see the advantage of I2C protocol. The biggest advantage is it is a low power protocol. Flexible data transmission rates. Only 2 signal lines are required. Easy to use and simple to implement since less hardware is involved. Capable of handling multiple masters and multiple slaves by providing arbitration and communication collision detection. Now the disadvantages are slower data transfer rate than SPI. The size of data frame is limited to 8 bits. It cannot be used for long distance communication. Introducing a new device to the existing communicating network is very difficult. Now these are the applications. Accessing low speed ADCs and DACs, controlling LCD displays, accessing real-time clocks, and onboard communication between the ICs. So this was all about I2C protocol. Thank you.